For millennia, humanity has looked to the stars, wondering, are we alone in this vast, mysterious universe? The question has haunted poets, scientists, and dreamers alike, echoing through every culture and every age. Today, that question echoes louder than ever, as our technology brings the cosmos closer, and our curiosity grows ever more insistent. The James Webb Space Telescope, humanity's most powerful eye in the sky, has made a discovery that could change everything. A planet with a 99.7% chance of harboring life. This isn't speculation, it's data, the result of years of rigorous science, careful observation, and tireless analysis by teams around the globe. For decades we've searched for signs, sent messages into the void, and scanned the heavens for any hint that we are not alone. We've listened for whispers in the cosmic static, hoping for a signal, a pattern, a clue that life exists beyond Earth. Now, we have more than a whisper, we have evidence. The data is clear, and the implications are profound. The planet, Gliese 514b2, shows chemical fingerprints, oxygen, methane, and other biosignatures that even the most skeptical scientists can't ignore. And this is a turning point, the culmination of generations of dreaming, engineering, and relentless pursuit of knowledge. Every mission, every breakthrough, has led us here. The implications touch every part of human culture, science, philosophy, religion, art. Our understanding of life and our place in the universe is about to change. The number, 99.7%, is almost impossibly high for science, which usually avoids absolutes. It's a figure that demands attention and invites hope. Yet, the data is so compelling that caution gives way to excitement. In labs and observatories, scientists celebrate, knowing they stand on the threshold of history. We've found a world that looks, smells, and feels, chemically, like a living planet. Its atmosphere teems with the markers of life as we know it. The silence of the universe has been broken. For the first time, the cosmos is whispering back. We are listening, and for the first time, we may not be alone. The possibility is real, and it's electrifying. The journey to confirm this will be long, filled with challenges and new questions, but the first step has been taken. Humanity is ready to explore further. Humanity stands at the edge of a new cosmic era, united by wonder, and ready to embrace the unknown. To grasp this discovery, you need to know the tool behind it, the James Webb Space Telescope, or JWST. Launched in 2021, JWST sits 1 million kilometers from Earth, shielded from the sun by a massive sunshield. Its mission, to see the universe in infrared, peering through cosmic dust to the dawn of time. But JWST does more. It analyzes the atmospheres of exoplanets. When a planet passes in front of its star, JWST captures the starlight filtered through its air. By studying which colors are missing, scientists decode the planet's atmospheric makeup. This lets us spot the chemical fingerprints of life, biosignatures. Before JWST, we could only guess at exoplanet atmospheres. Now, we can detect even trace gases, revealing worlds like Gliese 514b2 in unprecedented detail. JWST is our life-finding machine. The story begins with a faint, unassuming red dwarf star, Gliese 514, nestled quietly in the vastness of space, just 25 light-years from our own solar system. Though it may seem distant in cosmic terms, it's practically in our neighborhood. Red dwarfs are the most common stars in our galaxy, and their habitable zones are much closer in than those of stars like our Sun. This makes them ideal targets for planet-hunting telescopes like the James Webb Space Telescope, which uses the transit method to spot distant worlds. During a routine survey, JWST detected a subtle dip in Gliese 514's light, a telltale sign of a planet passing in front of its star. This new world, named Gliese 514b2, was small, rocky, and intriguing. Gliese 514b2 orbits its star every 12 days, placing it right in the so-called habitable zone, the region where temperatures could allow liquid water to exist on its surface, a key ingredient for life as we know it. The discovery of a rocky planet in this zone was thrilling for astronomers, yet a planet's location alone isn't enough to confirm the presence of life. More evidence was needed. The real breakthrough came when JWST captured the planet's transit. and analyzed the starlight filtering through its atmosphere, searching for chemical fingerprints. The data revealed not only water vapor and carbon dioxide, but also a surprising mix of gases that didn't fit any known geological or non-biological process. On Earth, this particular combination of gases is produced almost exclusively by living organisms, raising the tantalizing possibility that something similar could be happening on Gliese 514b2. The research teams checked and rechecked their findings, scrutinizing every detail to rule out error or contamination. The evidence held up under intense examination. This was no ordinary candidate. For the first time, astronomers had found a world with a living, breathing atmosphere, one that hinted at the presence of life. The announcement sent shockwaves through the scientific community and captured the imagination of people around the globe. For the first time in human history, we had a real, tangible sign that life might exist beyond Earth, a discovery that could change our understanding of the universe forever. The search for life among the stars had found its most promising target yet, opening a new chapter in our quest to answer the age-old question, are we alone? A planet's air tells its story. The atmosphere is a living record, shaped by everything that happens on the surface and deep within. It's a chemical diary, revealing secrets about the planet's past, present, and even its potential for life. Using the powerful James Webb Space Telescope, astronomers peered into the skies of Gliese 514b2. They discovered its atmosphere is rich in oxygen, a gas that doesn't last long unless something is constantly making more of it. On Earth, oxygen is a signature of life, and its presence elsewhere is a tantalizing clue. Alongside oxygen, JWST also detected methane. On our own planet, methane is mostly produced by living things, from tiny microbes to grazing animals. Its presence on Gliese 514b2 raises even more questions. Oxygen and methane are chemical opposites. They shouldn't coexist in large amounts for long, because they react and destroy each other. Their simultaneous presence hints at something extraordinary. On Earth, only powerful, ongoing processes, like photosynthesis and biological activity, can keep both gases in the air. Their presence together on Gliese 514b2 suggests something similar might be happening there, perhaps even life itself. Even more striking, JWST found dimethyl sulfide, a complex molecule produced on Earth almost exclusively by marine life, especially plankton in our oceans. This is a rare and compelling find. This trio, oxygen, methane, and dimethyl sulfide, creates a chemical imbalance that's hard to explain without biology. It's a combination that, so far, only life has managed to sustain. Geologists and chemists have worked tirelessly to find non-biological explanations, volcanoes, exotic chemistry, or unknown geological processes, yet none of these ideas fit the data we see. Every known abiotic model failed to reproduce these ratios. The simulations just don't match reality, no matter how creative the scenarios. The evidence overwhelmingly points to life. It's the simplest, most convincing explanation for what we're seeing in Gliese 514b2's atmosphere. Science never deals in absolutes, but this is as close as we've ever come to finding a living world beyond our own. Gliese 514b2's air is alive, whispering the possibility that we are not alone in the universe. How do we get from squiggly lines to 99.7% certainty? Scientists use Bayesian analysis, updating probabilities as new evidence arrives. Thousands of computer models, both with and without life, are compared to the data. Only the models with a biosphere match the observed gases. Abiotic models fall short. The result, a 99.7% probability that life is the best explanation for what JWST has seen. What might Gliese 514b2 be like? It's likely tidally locked, one side in perpetual day, the other in endless night. The habitable terminator zone between day and night could host vast oceans and mild temperatures. The red dwarf sun would hang low, casting a permanent reddish twilight. Plants, if they exist, might be black or purple, absorbing the dim red light. The air would be humid, rich with oxygen, and tinged with the scent of dimethyl sulfide. Strange, slow-moving creatures might graze on alien foliage, while oceans teem with microbial life. All this is speculation, but the chemistry is real. Life here could be utterly different, maybe not even based on DNA. But it is alive, processing chemicals, shaping its world. We're not just looking at a rock, we're seeing a living planet. The discovery is of a functioning planetary-scale ecosystem. This discovery is just the beginning. The next step, confirmation. JWST will dedicate more time to Gliese 514b2, gathering more data. Scientists will look for seasonal changes in gases, more biosignatures, and map the planet's climate. Future telescopes may even capture a direct image, a single pixel, revealing oceans or continents. The ultimate dream, sending a probe. It's far beyond our current reach, but now, we have a destination. The quest to reach Gliese 514b2 could define the next century of exploration. For all of history, we knew only one example of life, ourselves. The discovery of life on Gliese 514b2 changes everything. Life is not a miracle, but a natural outcome of the universe. If it happened here and there, it could be everywhere. The galaxy may be teeming with life. We are not alone. We are part of a vast cosmic web. This realization will reshape our philosophy, our sense of place. We are not the center, but one voice in a cosmic choir. We haven't met aliens, but we've detected their breath across space. Humanity's story is now part of a larger galactic narrative. We stand at the shore of a new cosmic ocean, ready to take the next step. The universe will never look the same again.